Okay, so let's get started on trigonometry. This is the function and graphs lesson number 4, how to find an angle from a trig ratio. So there's a little bit of a review at the top here that says when you had used SOHCAHTOA in previous courses, we always combine the sine of the trig ratio or the cast ratio and sine, cos, and tan to find what we call a reference angle. So for the following process to determine an angle measure between 0 and 360 degrees, we always want to determine the quadrant the angle would be in. So that's your cast rule. So I'm going to write CAST next to it. Once you have your quadrant, you can use the second function button. So second function sine brings up the sine -1. You can do second function cos, which brings up cos inverse or cos -1. And tan inverse or tan -1. So these aren't actually your reciprocal identities. These are the inverse functions, which is going to undo the function sine, cos, and tan and give you an angle. So it's important here that when you're determining the reference angle, you want to use the absolute value of the given quantity. You don't want to write in cosine of -1/2 because it's going to mess up your reference angle. So making sure you use the positive of that and then determine the reference angle based on the information you were given and the quadrants you could be in. So always check your domain for the calculation. Make sure that the solution you're about to state is within the domain. So they're going to say something like 0 to 180 or between 90 and 180. And in this unit, we're going to stick to that 0 to 360, but we can potentially see greater than that as well. So here's example number 1. Complete the following to solve cos theta equals -0.5, where theta is between 0 and 360 degrees. So we're looking for an angle between 0 and 360 such that this would be true. So the first thing we want to do is say, based on the cast rule, what quadrants is this in? Cosine is negative, so that leaves me in quadrant 2 or quadrant 3, because in 1 and 4 they'd be positive. So I'm going to write quadrant 2, quadrant 3. We want to determine what would be the reference angle. So to do that, we need to grab our calculators. Make sure you're in the mode in which you want your answer in. So in this case, they want the answer in degrees between 0 degrees and 360 degrees. So I'm going to switch modes to degree. And then I have to type in the question. Because it says cos theta is a -1/2, I want to find the angle. To solve for the angle second cos brings up the cos -1. Again, we put in the absolute value, so don't put in the -1/2, put in +1/2. And my reference angle is 60 degrees. And then we have to take on the information we're given and say, in quadrant 2, in that first quadrant we're going to consider, here's quadrant 2. If the reference angle was 60 degrees, what would be the rotation angle? And so in this case, we'd be 60 degrees away from 180, or the rotation angle would be 120 degrees. And in quadrant 3, if I was 60 degrees past 180, 60 plus 180 would be 240 degrees. So there's actually two solutions for theta, 120 degrees or 240 degrees. Okay. Class example number 2. Given that sine theta all squared could be written as sine squared theta, solve the equation sine squared theta equals 0.5 on the interval between 0 degrees and 360 degrees. So I look at my domain. The domain is in degrees. So I need to state my solution in degrees. So I'm going to stick in degree mode on my calculator. They had told me that this sine squared theta could be written as sine theta squared. So that's the first thing I'm going to do. Sine theta squared equals 0.5. I'm going to square root each side to get sine theta. And I'm going to take the positive and the negative root. So I'm going to say positive and negative 0.5. Now, because I square rooted and I took the positive and negative root, this tells me I could be in all 4 quadrants. Because if I take the plus of that plus minus symbol, I will be in quadrants 1 or quadrants 2. And if I take the negative, I'll be in quadrants 3 or quadrants 4. So the next thing to do is figure out the reference angle. So sine theta is root 0.5, so I want to find out what is theta. So second sine root 0.5 in degrees, 45 degrees. Now, when I solve for that, I want to make a note that this is the reference. So 45 degrees reference angle in every single quadrant. So I'm going to list 4 solutions. I'm going to say theta could be 45 degrees in quadrant 1, 180 minus 45, or 135 degrees in quadrant 2, 180 plus 45, or 225 degrees in quadrant 3, and 360 minus 45, or 315 degrees in quadrant 4. And all 4 of these fit that domain 0 to 360. Okay? So we're combining the cast rule with our second function button to find the angle. You're only going to use the second function button when you want the angle. So what about these reciprocal trig ratios? So since there's no calculator keys for cosecant, secant, or cotangent, you always have to use the reciprocal ratio of the primary form. So that means you need to write 1 over sine or 1 over cos or whatever. So for example, to solve cotan x equals root 3, write this in the form tan equals 1 over root 3. So I want to explain how they got this, because we said here, okay, so cotan x is root 3. I could state 2 things. So first thing I could do was to reciprocate this left side here, use the definition of cotan related to tan. The reciprocal of tan, I should use x if they're using x. 1 over tan x would be root 3, but I can use an equivalent expression which says it's kind of like you want to reciprocate both sides. If I reciprocate this side, I get tan x. If I reciprocate the other side, 1 over root 3. And it makes sense, because if cotan x is root 3 over 1, then tan is the flip, or the reciprocal of cotan, would be 1 over root 3. So we're always going to try to leave that primary ratio there. We don't want the primary ratio in the denominator, so we want the primary ratio kind of on the one line, and we'd rather reciprocate the other side. In the end, we did reciprocate both, because cotan, the reciprocal is tan, root 3, the reciprocal is 1 over root 3. Okay, so solving this between 0 and 360, I'm taking a look. Tan is a positive 1 over root 3. So that means I could be in quadrant 1 or quadrant 3 for tan to be positive. I need to figure out what angle is associated with that. So I'm going to second tan 1 over root 3, 30 degrees reference angle. So I'll go and state solutions in both quadrants. So in quadrant 1, that would mean if the reference angle is 30, I'd be 30 degrees away from 0. In quadrant 3, I would be 30 degrees past 180. So in quadrant 3, x equals 180 plus 30, or 210 degrees. Okay, if this was restricted such that I had to reject one of those solutions, we could. So determine the measure of x to the nearest degree where x is between 0 degrees and 360 degrees. So similar to what we've done up above, secant, decide what it's related to. Secant, that's a non-cos, it goes with cos. So secant and cos are related. So I reciprocate, or take the reciprocal of secant is cosine. I'm going to take the reciprocal of this answer. So 1 over negative 1.2631. Now I have to solve for x. Cos x is 1 over negative 1.2621, so it's negative. So by the cast rule, cosine is negative here and here. So in quadrant 2 and quadrant 3, we're going to use the positive version of this to figure out what the reference angle is. If we throw that negative in, it's going to potentially give us an angle between 0 and 180, and we want the angle kind of between 0 and 90. We want that reference angle. So I'm going to say, okay, I was solving, cos x is this number, so I'm going to hit cos inverse, solve for x, undo the cosine, 1 over 1.2631. Reference angle to the nearest degree, 38 degrees, so I got 37.6 on the calculator. So the reference angle is 38 degrees. So we're going to state two solutions for our quadrants. So I like to draw a picture almost again. Say, okay, what if I was 38 degrees away here and 38 degrees here? And then we'll do a little math. 180 minus 38 if I was in quadrant 2, or at 142 degrees, or 180 plus 38, 218. So there's two solutions between 0 and 360, 142 and 218. Okay. Cosecant x equals 2.45. Cosecant x related to sine, so the reciprocal of cosecant is sine x. The reciprocal of 1 over, or the reciprocal of 2.45 is 1 over 2.45. So I'm going to solve this. Actually, first, before you solve it, state your quadrants. Sine is a positive number, so, and cosecant too, and cosecant is related to sine, C-A-S-T, which means if sine is positive, quadrant 1 or quadrant 2, figure out what the reference angle is by taking the second function sine, undoing the sine to solve for x. 1 over 2.45, 24 degrees to the nearest degree. So we can even make a note here that the reference angle is 24 degrees because we haven't stated a solution yet, but in quadrant 1, 24 degrees is the first solution. In quadrant 2, we would have 180 minus 24, or 156 degrees. Okay. So just remembering you're using your cast rule, solving for the angle. So determine the measure of theta to the nearest whole number where 0 degrees less than or equal to theta less than or equal to 360. So cos theta is 0. So we don't want to say 0 is positive or 0 is negative. So I'm guessing this is on an axis somewhere, an x or y axis. So let's figure out what the reference angle associated with that is. Let's undo the cos. Let's solve for theta. Cosine is 0. My domain is in degrees, so I'm just going to stick in degree mode. Cosine is 0 means the reference angle is 90. There are two places where the reference angle is 90, either 90 degrees away from the x-axis, either way at top at 90 degrees, or 90 degrees away from the 0, 180 axis at 270 degrees. So two solutions for theta, 90 degrees and 270 degrees. Where would cosecant theta be undefined? So, question is, how do we get something that is undefined in math? Typically, dividing by 0. So this is kind of like saying, where is cosecant theta 1 over 0? And it doesn't matter if the 1 was there, you could put a 2, a 3, a 4, whatever you want. Because the point is, if you reciprocate cosecant, so the flip of cosecant or the reciprocal of cosecant, cosecant related to sine, if you flip sine, you'll reciprocate this side so that now it's 0 divided by whatever number you put there, or 0. So in other words, where is sine theta 0? Probably on an axis. Let's check. reference angle is 0. So a reference angle of 0 means you're at 0 or you're at 180. I should put degree symbols on these. Or we could say between 0 and 360, you're also back at 360 degrees. So 3 solutions there: 0 degrees, 180 degrees, and 360 degrees. Okay, so working in radians is similar. You're going to use your cast rule and then just finding the actual rotation angle once you have your reference angle is just going to require a little more work. Because what's going to happen is that when you determine your quadrant, then your next step is to do the second function, and you're going to get a measure of radians, basically a decimal. And so we want to work in pi, if we can, as fractions of pi, and then decide to add or subtract fractions of pi from our x-axis, which I'm just going to label on one of these. Starts at 0. Pi radians is at the 180 position, and then when you come back to 360, it's 2 pi radians, okay? So let's try one first. Now it says, in each case, determine the value of theta to the nearest hundredth of a radian. So I need my answer in radians. I'm going to make sure right now I switch modes. So switch to radian mode. Okay, I'm going to double check. There we go. So we're back in radian mode, solving to the nearest hundredth of a radian. So not as an exact value of pi, to the nearest hundredth of a radian, where is cosine negative 0.5? Cast rule first. Where could cosine be negative? Cosine could be negative where sine and tan are positive, so in quadrant 2 and quadrant 3. Figure out the reference angle in terms of the radians, or in terms of the, we're going to have to round it to the nearest hundredth, I guess. So second cos, where is cosine? 0.5. 1.05. I'm going to write the reference angle, 1.05 radians, which means I have to figure out what is the rotation angle there in quadrant 2 and what is the rotation angle there in quadrant 3 if the x-axis represents pi now and not 180 degrees. So before I was taking 180 degrees and adding my reference angle, subtracting my reference angle. Now I'm going to take pi, I'm going to subtract the reference angle, add the reference angle. And in fact, I'm just going to keep all decimals on my calculator so that I have them easily saved and more precise than if I had rounded. So the first one in quadrant 2, I am 1.05 radians approximately away from pi. So let's type in pi minus my answer, 2.09 radians. And then I am 1.05 radians above pi approximately. So I need to find a way. I need the fancy calculators you guys have so I can copy and paste this. Pi minus 1.047195 will be good. Oh, did the same thing. Pi plus 1.04719. I want quadrant 3. And I'm really messing this up here. Pi plus 1.04719. Okay, there we go. 4.19 radians. Okay, so just a rule of thumb, you're not going to work in decimals long, but if you can, try to take greater than 3 decimal spots. I typically say 5 when you're adding and subtracting with pi, just because that thousandth position, you don't want it to throw you off. Okay, so cotan theta, where is cotan theta equal to negative 5/4? This is a reciprocal identity, so I'm going to reciprocate it back to tan, and I'm going to flip my fraction to negative 4/5. Tan is negative, so by the cast rule, that means I could be in quadrant 3, no, quadrant 2 or quadrant 4, where the C and the S is. we have to use the absolute value in radian mode to figure out what the reference angle is. So I'm taking the tan of 4/5, don't type in negative 4/5, 0.6747, so the reference angle 0.67474 radians. In quadrant 2, I would be just short of pi, so I'm going to go pi minus 0.67474. Got 2.47 to the nearest hundredth. And then in this quadrant, I'm coming up on 2 pi. So I'm 2 pi minus my 0.67474 radians. It's 5.61. So I'm going to clarify there's two solutions. Theta equals, oh, look at, they tricked me. I'll show you. I'm going to write both solutions and I'm going to show you why they tricked me. 2.47, 5.61. So if I was reading carefully, this one said between 0 and 2 pi. So both of my solutions here were between 0 and 2 pi. If I had read closely, it said between 0 and pi. So I actually did not need to find the solution in quadrant 4. Between 0 and pi, there's one solution. That's outside the domain. Your only solution, 2.47 radians. Okay. Last page here. So this one is tricky because we want radians as fractions of pi, and almost 90% of the time we work with radians as fractions of pi. So when we want to convert the answer to pi, this is going to be kind of our process. So you're going to hear me say the word that pi is built into the radian. So if pi is built into the radian, take your answer, divide pi out, and then hit math fraction to get that fractional part of the radian, that rational part, whether it's 4/3 or 2/3. And then once you have the fractions of radians, we can deal with the fractions to figure out what our rotation angle would be. So if we get a reference angle of pi/3, then we'll be taking things like pi plus pi/3 or pi minus pi/3, and we really treat them as fractions and we ignore the pi's there. Okay, so let's try right here. In each case, determine the exact values of theta in this interval 0 to 2 pi for which sine theta would be 1/2. So first thing I'm noticing, sine theta is positive 1/2. Come up with two quadrants where sine is positive. Sine is positive in quadrant 1 and quadrant 2. If you like to do another labeling showing me that this is 0, this is pi, you could go again, this is pi/2, 3 pi/2, and 2 pi, it will help you write your rotation angle. So just a quick sketch on where your axes are in terms of pi. Okay, sine theta 1/2. So what happens when we take sine theta and of 1/2 and we want to find theta? We take second function sine 1/2. I can type in 1/2 or 0.5 if you, whatever. It's going to give me the same answer. So to be exact, I'll just use 1/2. So sine theta 1/2, or to copy the book, we'll use 1/2. Okay, so this is what happens. I get 0.523595, blah, blah, blah. So something radians. Not a nice number, not a multiple of pi. Now I'll show you what happens if you try to math fraction this right now. Nothing, because pi is built into it, and pi is an irrational number. So you need to divide pi out of this so that now you have a repeating decimal, in other words, a rational number that creates a nice fraction. So the fraction is 1/6. So I know my reference angle then is going to be pi/6. In quadrant 1, that would be 0 plus pi/6, or pi/6 for theta, quadrant 1. In quadrant 2, that would be pi minus pi/6. Now I don't want to type in pi minus pi/6 on my calculator because it's going to give me decimals again. So treat this as numbers. This is 1 whole, subtract 1/6, or 5/6, 5 pi over 6. So there's two solutions for theta. Theta could be pi over 6 in quadrant 1, 5 pi over 6 in quadrant 2. Okay. Where would secant theta equal -√2? So I'm going to draw my cast rule. Secant related to cos. So if I want to reciprocate secant back to cosine, cosine theta -1 over √2. Cosine is negative. So two quadrants, quadrant 2 and quadrant 3, where cosine would be negative. In radian mode, figure out what is the angle associated with that. So second cos 1 over √2, don't type in the negative, absolute value. So 1 over √2 gives me 0.78 something something. Now I get excited, I'll hit math fraction, nothing will happen. So you can't fraction the pi right from here. Pi is built in, you have to divide pi out. 0.25, that's going to make a nice fraction, 1/4. So the reference angle is actually pi over 4. And then you have to decide what you're going to do. So here we've got pi. If we want to label it again, we're just behind pi or short of pi. Pi minus pi over 4, which is 1 minus 1/4, which is 3/4, or 3 pi over 4. And then 1/4 plus pi over 4, or 1/4 past pi, so what, pi plus pi over 4? Be 1 plus 1/4, which would be 5/4. There's two solutions for theta, which would be 3 pi over 4, 5 pi over 4. Okay, where is cosecant theta? Undefined. So cosecant's related to sine. It's undefined because I divided by 0, which means if I reciprocate sine, I'm going to get 0. Where is sine theta 0? It's going to be on an axis with a reference angle of 0. So between 0 and 2 pi, where there's a reference angle of 0, we could say theta is equal to 0 radians, pi radians, and we'll include 2 pi because it's included in the domain here. So 0 radians, pi radians, or 2 pi radians. Okay, you guys can get started on questions 1 till 11. We'll tackle the unit circle tomorrow, and then we're ready for an assessment. Okay, thanks.